If it's straight,
All right.
it's not.
If it's speed, horizontal, and or both consequence velocity, it can only be straight.
Any questions?
If it's going for a full tangent, then it's accelerating.
Okay.
I have a question.
Yes,
I can turn the master set through Blackboard, correct?
you should be able to. Has anyone tried submitting Master Set 2 through Blackboard and had problems?
For mine, it says that it's overdue because the due date was set on the 4th.
Yeah, did it stop you from submitting?
I haven't tried. I
Okay.
was just wanting you to know that. I didn't know that.
Yeah, oh, yeah, the dates get set early, and I just haven't bothered changing them.
Okay, it's okay. I just do.
Yeah, it's not really
Even if it's-
overdue.
Okay.
And I might have figured out how to set it so that it doesn't automatically give you a 0.
All of our classes. That's right, so yeah, zero teacher at all.
Alright, so, what was the last thing we did? So, like 3 classes, all roughly similar places. We did the tough, the hard projectile motion problem.
Yeah.
Alright, okay, so we've assigned tests there. Did we start on F-Tom?
No.
That's where we will begin. Eventually that will come up. All right, so we're about to actually do the first bit of real physics. The stuff that we've done so far really is math and definitions. I first learned about the whole position, velocity, acceleration stuff through calculus and not through physics. But we're about to embark on what would be considered physics by all accounts. And more importantly, what I consider the most important equation in all of the course.
Are you specific about, are you case sensitive in this case? Does F have to be capitalized?
That is the typical symbol for force.
Alright,
That F stands for the total force acting on a mass M, and A, lowercase a, represents the acceleration. Now, as we explore this, we've already explored acceleration. Let's explore force. Now, for the sake of what we are doing in here, there's sort of a checklist that I have when looking at forces. So as you analyze a situation or a problem, just sort of run down the list in your head. The first F here stands for friction. And the symbol I will be using for friction is sort of a fancy lowercase f, actually a little curl in there. But I
so
sometimes
like a
will-
forte in music?
I don't know. It's been a long time since I've
Okay.
been up on that stuff. Sometimes refer to it as the Baroque F, but anyway, that's the symbol I'll be using for friction. Some textbooks will just, instead of doing that, some textbooks will do a capital F with a subscript F. That's fine too. T stands for tension. Now the symbol I will use for tension is an F with a subscript T. Some people will use a capital T for tension, and I used to, but at some point later in the course, probably sometime point in November, we'll have an equation that has tension and period in it, and period, the symbol for period, since it is a time, is a capital T. So instead of using capital T for tension, and then at that point going, okay, now we're gonna change it, we're just gonna use F sub T for the symbol that I will use. If on a test you use a capital T for tension, at this point, I know what you mean. O is for other, as I needed to vowel, and also sometimes there are forces in a problem and you have no idea what causes it. The symbol is problem specific. Problem specific. N stands for normal. The symbol I use for that is a capital Y. For two reasons. One, it's what my high school physics textbook used, and it's sort of ingrained. And also, we don't use capital Y for anything else. And G for gravitational. Now, there are two types of gravitational force, depending upon the situation. There's a general form, which we'll get to in chapter 6, I think it is. And then there's what we'll be using initially. So there's W, and then F sub G. F sub G is the generalized form. W stands specifically for weight. Some textbooks for normal force will use F sub N. Sometimes lowercase, sometimes uppercase. If you do want to come up with your own symbol for normal force to use in a problem, please don't use a capital N for the actual symbol in the math equations.
F sub N is for normal, you said?
Yeah, some textbooks will do that, yes. Questions up to here? All right, each of these forces has a certain requirement. The other forces that we will run into will sort of add as we go. The requirement for this to exist, The requirement for friction is there must be contact and desired relative motion. So contact is not enough. For instance, if everything is level here, there's no friction between my notebook and the table, because if it were frictionless, assuming everything's level, the notebook has no desire to move one way or another. So the desired motion is not there. Tension requires a taut rope, chain, etc. There's some sort of pulling going on. Other, the requirement is a force with an unknown source or a force I'm trying to think how to word it. Say a force with an unknown source or
A force with a known source.
no, a force with a source we don't care about. bad grammar. Or force with a source about which we do not care. And I don't mean in terms of your life philosophy and what you're gonna be doing for a living, in terms of physics, that it's irrelevant. That's probably a better, shorter term. It's a force with an irrelevant source. An example of other would be, I have a box with a 5 Newton force pushing on it. I did not state what was causing that 5 Newton force. That's an example of other. It usually is stated as part of a problem where they just randomly throw in some force.
Are the forces within and whatnot, are those still part of tension and are those requirements, or is that example?
What? Sorry, for that? Those are-
Underneath your arm. Yes.
That's for other.
Okay, thank you.
Normal force requires contact. Generalized gravitational force requires 2 masses. Weight requires 2 masses because it is a gravitational force, but more specifically, so 2 masses where 1 mass is, I'm going to put small in quotation marks, and the other is huge. And what I mean by huge, planet, sun, star, moons, those would be considered on the huge side. Oh. And the other part of that is the small mass. So an elephant would be considered small in this context. Small mass is near huge mass. So if I am on the moon and the Earth does have gravitational pull on me because we're 2 masses, I have gravitational pull on the Earth as well. But that would not be considered weight. The force that the Earth exerts on me is not considered weight because I'm not near it. All right, questions up to here?
Please don't erase that.
Now, in physics, there are not many times that you can get away with the word always. I think I've mentioned before. One of the cases is a change in a quantity is always the final value minus the initial value. That's an always. Another one for classical physics, which is what we're doing, is that forces and that's supposed to be an R there. Forces always come in pairs.
So, for a relevant question, I think a large mass is anything on a universal scale.
Yeah.
Okay.
Now, each force in that pair acts on different objects is the same type as the other. Same type. same magnitude as the other. Is in the opposite direction. It's in the opposite direction to the other. There is a
Is
bizarre.
that an I or a semicolon? In class?
Classical. It's
Okay.
not.
There are some bizarre exceptions that show up once you get into modern physics that it's just the pair hasn't happened yet. It's on the way to happening.
Are you
Yes.
going to like show us an example of this?
What this is?
Yeah.
Oh, absolutely. You will get plenty of examples. To the point where, if you're lucky, it'll be part of your dreams.
This one's scary.
I mean, that's not particularly hard for me.
All right.
I can continue my dreams after waking up.
So, since forces come in pairs, then when you are writing down these types of forces, how are the forces drawn in relation to each other? So this is direction with respect to WRT, each other. So friction, when you draw those forces, will be anti-parallel. Well, they're all officially anti-parallel, but they'll be side-by-side anti-parallel. Tension, when you draw a pair of tension forces, those forces will be pointing towards each other. Other is the case where you're only drawing one part of the pair, then the other one exists somewhere, but it's sort of off screen. So draw only one. Normal force, that pair of forces will be pointing away from each other, and gravitational force will be pointing towards each other. So things that are pulling things together, the arrows point towards each other. Things where they are pushing away from each other, so normal force pushes away. But we also have not only directions with respect to each other, all forces have a source and a receiver. So
Newton's third law, basically.
yeah, this is Newton's third law right here, for instance.
Thought so.
So the direction with respect to the objects. So friction is parallel parallel to the surfaces of contact, and it opposes the desired relative motion. I do recognize, just putting down a laundry list here, we will be hitting loads of examples as advertised earlier. Tension, it's parallel to the taut rope chain whatever happens to be pulling.
Parallel to pulled item, okay.
Well, gotta be careful about the wording there. All right, so I have a tight string right now. The tension force acting on the stopper is pointing this way, parallel to the tight string. The tension force that's acting on my hand is pointing that way. And as a side note, the tension that's pulling up on the stopper and pulling down on my hand are not part of the same pair.
Why is that?
Because I am no Jedi powers in classical physics. I'm not touching it. I'm not pulling on it. I'm pulling on the rope. The rope's pulling on it. So there's a pair between the rope and the stopper. There's a pair between the rope or string in my hand. Other is problem specific. There's a 5 Newton force pushing on a box to the right. Well, the direction is on the box to the right. Normal force is perpendicular to these surfaces of contact. Normal is a math term. Give you a chance to let us find out, give me a chance to find out what you know. What does normal mean in math?
Regular, which is probably, that doesn't help.
Not the math form.
Are you asking for a formula?
No, not a formula. All right, normal means perpendicular. So that's why it's called a normal force. And then gravitational force, it points toward the center of mass